Cogged wheel railway, climbing the steepest slopes. A cogged wheel railway, also known as a rack railway, is a specialized type of railway designed to operate on steep gradients where conventional railways would lose traction. This system uses a toothed rack rail, usually mounted between the running rails, and a cogwheel, gear wheel, on the locomotive that meshes with it to provide extra grip. Conventional railways depend on the friction generated between the train's steel wheels and the steel tracks. This mechanism functions effectively on level or slightly inclined surfaces. Nevertheless, on steep gradients, usually exceeding 7 to 10%, the wheels may start to slip, which can hinder safe ascent or descent. To address this issue, cog railways utilize mechanical engagement. The cogwheel guarantees that the train is securely attached to the track, thus avoiding slippage. The basic components of a cogged wheel railway include rack rail, a toothed bar placed centrally between the two running rails. Cogwheel, pinion A rotating gear on the locomotive that meshes with the rack rail. Specialized locomotives. These are either steam, diesel, or electric powered, and are built to operate with the rack system. This design allows trains to climb steep inclines, sometimes exceeding 45% gradient, and descend safely using the same mechanical grip. Several rack systems have been developed, including Riggenbach system, one of the earliest, using a ladder-like rack. ABT system uses 2 or 3 parallel bars with offset teeth for smoother operation. Strub system, a single flat bar with vertical teeth. Locker system, horizontal teeth used for very steep slopes, such as the Pilatus Railway. The first successful cogged wheel railway was invented by Sylvester Marsh, an American engineer and businessman. He designed the system in the 1860s after experiencing the difficulty of climbing Mount Washington in New Hampshire. Marsh's invention used a ladder-like rack rail placed between the running rails. A gear wheel, cogwheel, on the locomotive would mesh with this rack, giving the train traction even on steep gradients over 30%. Many people at the time thought Marsh was foolish for attempting this idea, calling it Marsh's folly. But he proved them wrong. His system worked and became a major innovation in railway technology. Following the success of Marsh's railway, European engineers improved the design. Niklaus Riggenbach, Switzerland, built the first European rack railway in 1871, using a similar design. Roman Abt later invented the Abt system, 1882, using 2 or 3 toothed bars for smoother operation and better traction. Some of the most well-known cog railways in the world include Pilatus Railway, Switzerland, the steepest in the world, 48% gradient. Mount Washington Cog Railway, USA, the first mountain climbing cog railway, opened in 1869. Jungfrau Railway, Switzerland, climbs through the Alps to Europe's highest railway station. Nilgiri Mountain Railway, India, uses the ABT rack system on steep gradients. Although the majority of cog railways currently cater to tourism and heritage needs, particularly in hilly areas, a few continue to operate for public transportation or industrial applications. Contemporary rack railways typically incorporate electric traction, automatic braking mechanisms, and sophisticated engineering to improve both safety and efficiency. From the 19th century to today, this simple but powerful idea continues to connect people with the peaks. The cogged wheel railway is a brilliant example of mechanical ingenuity, enabling rail transport in regions where traditional trains would fail. By combining friction-based and gear-based movement, these railways open up access to high-altitude destinations and offer passengers breathtaking views along the way. Brought to you by Untold Facts from Maroli Edutech. Thanks for watching. Please share and subscribe to our channel for more informative videos.